Hi, welcome to our nice workshop about Calm the Storm. So, what is this workshop about? So, today we're going to talk about building a retail end-to-end event-driven architecture platform on Azure with Solace in just 60 minutes. So, stay tuned if you want to learn more. Hi, my name is Patrick Polster. I'm a cloud consultant with Thinkport, and what Thinkport exactly is going to be introduced by Dominik, our CTO.
Yeah, thank you, Patrick. Yeah, as Patrick said, I'm Dominik, CTO and founder from Thinkport. And we are a small company based on Frankfurt. And we're doing a lot of stuff with event streaming in the cloud, especially. And we are also a close partner to Solace and have the strategic partnership with Solace for Germany. Before we start hacking, we want to show you what's all about today. For this, first of all, Patrick will introduce you in the use case. And after that, I will explain you the architecture. And then we will try to hack live. And hopefully at the end of the talk, we will have the complete end-to-end pipeline ready.
Okay, so today we're going to talk about a use case which is based in the retail markets, you could say. Basically, what we are going to have a look in detail is the process of a good being purchased in the retail market. So on the one hand, we have a checkout system where a specific good is being processed, is checked out. So the good is sold to the customer, and our system is getting notified by an event with the article bought event, and then we are going to register this event to a database and persist this information. And on the other hand, we're going to deliver this message or this event to our supplier, which is going to be informed that an article was bought. In between, we're going to filter out some information so that all information is going to the supplier. Okay, so Dominik, let's talk about the architecture.
Yeah, first of all this stuff which Patrick told is already finished in the event portal in Solace from our virtual architect from the retail system. So it's not something we will create in this session. But Patrick will show us a little bit more in a few seconds about this event portal. For the overall architecture, so we are based in Azure, Microsoft, and all the stuff we are showing right now will be provisioned in Kubernetes and in Azure. For this, we have some virtual clients which will sending data to Solace, the pub/sub broker, which is also running in Kubernetes. And then we have different microservices which will produce and consume the data from Solace and transform it, as Patrick explained. And then there's a cool feature like named REST Delivery Points, or short RDP. And with this feature, it's possible to subscribe some endpoint, and then the data will be pushed automatically to Azure function, for example, or service bus. So we don't have to build some code for this. The Azure function is inserting the data in the Cosmos DB. So all the stuff on the right side will be triggered automatically. So we only have to insert some small code snippet in the Azure function, and then everything will be going automatically. Okay, now let's get our hands dirty, and we want to start to provision the different Azure services. Normally we would do this with Terraform, but today we will just click us through the Azure portal. First of all, we will start with Kubernetes, and then we will provision the Solace broker. And after that, the Azure function, Cosmos DB, and the different microservices. Okay, so then let's switch to the Azure portal. Okay, this is the Azure portal. And as I said, first of all, we will build the Kubernetes service. For this, we can just type Kubernetes here. So to switch to the Kubernetes service, where it's possible to build different Kubernetes services for different resource groups or subscriptions. If you don't know, a subscription is a like of account where different resources are bundled there, and for a more detailed bundling, there's this kind of resource groups. So it's like a collection of different services in Azure. So if you build different services in one resource group, it's like a kind of collection for this. And that's why if you create a new Kubernetes service, first of all, you have to choose your subscription. In a production kind of way, there would be, for example, one subscription for every layer, like dev, test, and production. We will just use our sponsoring subscription from Azure. Then after this, we have to create or choose some resource group. Because we build from scratch, we have to create one. We just name it resource group minus Solace. It's just a text. After that, we have to choose a name for the cluster. It has to be unique over the subscription. So we will choose KAS Solace. And then we have to choose some different options, like in which region we want to build up the cluster. We are based in Germany, so we choose West German. Then you can choose over which availability zones the cluster are stretched. This is very interesting because the cluster is with this option automatically stretched via different data centers in West Germany. So it has a very high SLA there. If you need some HR or DR settings, then you can just choose to build up it over different availability zones. It is a bit, it costs a bit more money, of course, if you choose more. So you have to decide if you need this or not. So today we only need one zone because we only build up a demo case, of course. Then you have to choose the Kubernetes version. We will choose the 1.19.7 version because we can. No other reason behind that. Then very, very important, we have to choose the Kubernetes node size. Of course, Solace and the clients have some different recommendations for this. We can stick with the recommended one, DS2 version 2, because for the developer broker, Solace broker, we only need about 8 gigabyte of RAM, and I think this is enough, right?
Yep.
Okay, great. Then we just choose this, and we only will choose 3 nodes at the moment. Of course, we can scale it up afterwards, and we could also create different node pools. I don't want to go this much in detail here. Just a quick introduction. You can create different node pools, for example, for different workloads, and we could now create a new node pool just for the broker and assign it to this node pool. So all the resources from the broker would only consumed from this node pool. So it's a very cool possibility to channel your resources. And of course, as always in the different services, you can choose some different authentication settings and also network settings. But for our case, we will use all the defaults here. And then after the review, you can just create it. And then it will take about 5 to 10 minutes. Okay, it took about 10 minutes for the creation of the AKS cluster. Yeah, now we will create the Azure function in a Cosmos DB. And after that, Patrick will continue with all the Solace stuff. Okay, then just switch back to the Azure portal, and then we will switch to Cosmos DB. And same as at Kubernetes, we just have to create a service. And as I already told, normally we would do this with Terraform infrastructure as code, of course, so we don't have to click here manually through the menus. But we want to show you how to build up this stuff per hand. Now we choose the same subscription and also the same resource group for that. And yeah, of course, Cosmos needs a bit different parameters than Kubernetes. First of all, there's also an account name. We just name it Solace Cosmos DB. Then we have to choose the API. Yeah, of course, there's a bit deep dive in Cosmos DB now. We will just use the core API, because the different APIs are just some abstraction of the core API. So the data itself, it's always the same, and you will just choose the interface here. So if you want to make it very fast, then just use the core API. For all the other things, just read the documentation. We don't go in detail here. Okay, because of performance reasons, of course, we also will choose the same location. It's here. Okay, then we will choose the free tier. We will choose account type non-production. We don't need an region support here, and we don't need an availability zone support here. So as you can see, we could install the Cosmos DB in a multi-availability zone setup as well, but we don't need it right now. Yeah, and of course we could set up some things like backup, encryption, network setups, and so on, but we use only the default here. Okay, and after validation, we can just create it. So in the meantime, we will just create the functions. The functions are serverless app like Lambda in AWS or Google Functions in Google. It's just a kind of code snippet where you don't have to manage some hardware under it or some virtual machine. It's just code where deployed on Azure, and it will generate automatically an URL for you, and then you can do some kind of offloading or from different services, or use it as a gateway to services. It's a very cool and functional feature. So for this, of course, also just use add. Then we can just use the same resource group as well. Then we need the function name, and as you can see, it's a part of the function name is a part of the URL as well. So we choose a good name for it, like Solace or function Solace Cosmos or something like that. Okay, then we can choose if we want to use a Docker container or code. We just want to publish it on a serverless kind of way, so we just use code. Then you can choose the language you want. Different language has different possibilities. for example, you can use Python but just on a Linux environment, and for that you have to download all your code in Virtual Studio Code, and then you have to code it offline. Today we want to show it in online in the online code. So we just use Node.js. Of course, region same as always, West Central. Then under hosting, we have to choose a storage account because of some kind of temp data. We will choose Windows as well because only in Windows currently it's possible to use the online editor. And then you can choose what the consumption plan is. If you have a high workload, for example, then it could be useful to choose the function premium part. Yeah, of course, we just want a kind of pay-as-you-go model, then just choose the consumption mod. Yeah, after this we will create it. Doesn't take this long, and if you are able to see it, the Cosmos DB is already deployed right now, provisioned. Okay, so now we have created the Azure function, the Cosmos DB, and Kubernetes itself. And now, of course, we have to build up some code here in the Azure function and create the initial structure in Cosmos DB, like a container and a database. And then all this stuff here is ready, and only the Solace part is missing. Okay, both services are ready now. First we will go to the Cosmos DB and there's this cool feature named Data Explorer, where we can just connect to the underlying Cosmos DB and create all the stuff we need. Yeah, first of all, of course, a database. For this we need a database ID, it's just a name. We call it retail DB, and yeah, then it's a bit technical here. We have to choose how much throughput we want. It's not this simple to calculate the throughput, so we don't want to go in much detail here. Patrick's got a lot of sessions about this in the past, how to calculate this, and especially in an event-driven setting. So yeah, we will just take 400. Of course, if your workload is very high, you have to choose a bigger number here. And there's also the possibility to outscale. Then yeah, Cosmos will choose automatically which scale it will allow at the moment. Yeah, so you have to decide based on your workload what you have to choose here. Yeah, we just go with 400 and then create the DB. And after this, we have to create a container in the DB, within the DB. So we want to use the retail DB, and then we have to choose a container ID. Then we have this article, was it called? Article.
Let's just call it article sold.
Sold, okay. Yeah, this is like business driven here, of course. There will be stored the data from Solace. So there should be, we should choose a name here which is business driven, and the partition key is important for scaling, of course, and this is a JSON path to our partition key, and we will choose the market ID here. This is a this is a column in our JSON, within our JSON.
I think you have to type it in capital letters, so market ID. I think the ID is no, the market itself is small, but yeah, the ID both letters are capital.
And just one T. Okay. Great. Good. Then the setup here is finished. And later on we can see in this data explorer how the data will income. So we can see then here the different items, and as you can see it's empty now. Then let's just switch to the function. Yeah, oh, we created one, right? Okay, I think it's in the different. Okay, it's this one here. Yeah, in the function we can, in the Azure function, we have now create some functions. These are the code snippets which will run if you, for example, make a post to the URL. So this is, for example, the overall URL, and then with the REST directory, you have to choose which function you want to call. And for this, we have to add a function here. And now you can choose where you want to code it. And yeah, of course, for a production or for the overall development process, you want to code it in an offline editor. Today we just want to hack something, so we choose the develop in portal option. And then you can so now you would be able to start, but we just use some kind of template, and Azure will create some boilerplate code, so we just have to add a few lines to finish up our function. And of course we will name it RDP. Okay. Now we create these functions, and then we can start coding here. Yeah, this is the code, and we can just adjust it here. But first of all, we build up the integration between the function and the Cosmos DB. For that, this integration tab is here. And now you can just add it here in this graph. It will pop up some parameters here. As you can see, we can choose between different bindings, and one of them are the Cosmos DB. Of course, you could choose different bindings as well. So we choose the Cosmos DB, and there we choose our created one, Solace Cosmos. And here we have to enter manually our database name and our collection name from Cosmos. First of all, the binding name. So we name it a bit more readable, output Cosmos. Then our database name. It was TP Retail, and our collection name was article. How was it called? I'm always forgetting stuff really quick. That's why I have to look it up again. So for you have to, oh sorry, it was the wrong one. just go to the Data Explorer again, then you will see the database name and then the container name. So it's retail minus DB, and the collection name is article minus sold. Okay, and that's it. And now you have to integrate the code for it. We added in the integration tab Cosmos, and it's automatically added here in the function JSON as well. You can see it here below with all the different parameters we set. For the code, we only need the name for the binding. So then switch back to the index. Yeah, we don't need this much code here. That's why, yeah, we can delete all the stuff, and we want to make it very clean here. So no, not much additional code. Yeah, the context is the communication between the integrations and all the stuff. And as you can see, there's yeah, a kind of auto completion here, but it not works this good. For example, it doesn't find the bindings. Yeah, so we have to go to context and bindings and then use our binding which we create. And then we just have to add the payload for the binding. And everything we will add here will automatically transfer to Cosmos. And our payload is in this object. And for this, we want to pass it in JSON. So we use the JSON parser, and then okay, it was raw body, right? Mm-hmm. Okay, good. So now we just get the data from Solace as it is, pass it in JSON, and transferred it to the binding, and the binding will automatically insert it in Cosmos. And now we will give back a kind of return value, and after this we can close the context as well. Okay, now we can just test it. Yeah, for that, just set up the HTTP method. And here you can just add some kind of things like a query parameters or some header informations, and of course adjust your payload. Yeah, we want to hand over the payload completely. So we don't check, for example, now the content here. We don't check the content here for some kind of business cases or something like that. And of course we don't make much error handling here as well. Okay, but let's try it, and hopefully it will work and the entry will be transferred to Cosmos. Okay, we just get in 201. That's good. And now let's switch here to the items. And great, we see the item here. Okay, now it seems to work. So everything we set up here is done. And the only thing we have to do now is to configure the REST delivery points in the Solace broker. And for that, of course, Patrick have to set up the broker in AKS, and he will also show how to configure the RDP here. And in the meantime, I will grab a coffee because it will take a moment. So yeah, Patrick, then just start with the broker stuff.
Okay, thank you very much. Okay, so as Dominik told you, he's actually grabbing a coffee, and in the meantime, we are going to deploy our Solace Pubsub Plus instance on our AKS. Additionally, we're going to configure it so that we are able to do the RDP push. And on the other hand, we are going to install or create a microservice that is able to consume from the Solace Pubsub Plus and also to push back into the system. So to make things happen, we are in the first place going to have a look at our deployed Kubernetes instance. Microsoft instantly provides you a connection string or a connection configuration, so that you have to execute those commands being provided, and then you're able to connect to your cluster. It actually utilizes some CLI commands, so for that we are going to do some shell magic. So see you in a second back in the shell. Okay, so welcome to the CLI. So the first command we are going to execute is actually the account set, so that we are changing the subscription we're currently in with our Azure accounts. So the AZ command is actually the Azure command line interface that you're just going to install on your computer. And with that, we just change the subscription. And additionally, we're getting the command to get our AKS credentials, which gives us a K8S context on our local machine, and we're able to connect to the cluster. So we just got the context and change it to the current context, and we're just able to get some kube control commands. And for the first, we're going to have a look at the namespaces. And with that, we verify that we're able to connect to the system and that we have all the default namespaces being created by, via AKS. We actually want to deploy our Solace broker in its own namespace so that it can live without interference from other namespaces. So the first thing we want to do is creating a new Kubernetes namespace. And call it Solace broker. So it is created, that is good. From here on, I'm going to talk a bit about the tool that you're handed over by Solace. So it's called the software event broker for Kubernetes, so that you have a kind of a quick start to get along with Kubernetes. The tool itself is also, there's also configuration provided by Solace, and the configuration is rolled out via Helm. So Helm is a package manager for Kubernetes, and we already installed it in our local machines, and also added the Helm repo that is required for this Solace installation. And additionally, we have had a look in how to install the Pubsub Plus broker via Helm. So here we just have to execute this command to get our results. So here it's installed via Helm a release. We call this initial release. And the chart we want to deploy, and then we configure the namespace we want to deploy in, and this is going to be the Solace broker namespace we just created, and let's have a look what is happening. So it returns some things actually. The most important ones are that we have the username, which is admin, and a password. We can get the password from from Kubernetes secret. So with that, we just want to echo it into our console so that we actually receiving it. So there we go. This is for now our password, and with this password we're going to log in to the console in a minute. But first of all, let's have a look what is actually being deployed. For that, we are going to have a look at the pods that currently exists on all the namespaces, and here we say that a container is being created with our initial release Pubsub Plus dev instance. So let's have a look what is happening in here. So we're just waiting for the logs being received. So this might take a while. In the meantime, I might get a coffee as well, but just wait a few minutes and then we see us when this is finished. Okay, from the logs I can tell that we actually finished installing our Helm release, and with that I mean our PubSub Plus broker. We can check for the port, which is actually responding that everything should run, and the port is actually on running. That looks good. Then we are going to check in the service tab for our external IP address, which was assigned to our load balancer. So the load balancer itself is actually created by Solace or by the Helm release for us, so we don't have to take care about this one, and we just get a public IP address, where with that IP address we're actually going to connect to the Solace PubSub Plus broker UI, so that we're able to manage everything from here on. So we are going to connect with the credentials we just printed out and with the IP address that was being provided. So see you in a minute when I logged into the console. Okay, so here we are at the login page of our Solace PubSub Plus broker. I'm just going to log in to see the message VPN we just created. So we have one default message VPN up, and in here we have our well-known Solace PubSub Plus broker UI. And from here on, we're able to configure all the details that when it comes to ACLs, connection, but also our RDP point. But we will do this later. First, we're going to have a look back at our application design in the designer, which is currently not connected. So the Solace PubSub Plus cloud deployment is not connected to our AKS running, but you might do this at a later point of time. But still the designer is working, so we are designing our application, how we intend to use it. We have our checkout system producing article bot events, and this event is registered in our article register database, so we get a know of it in our internal systems. And on the other hand, we want to notify the supplier. For the supplier, it is important that the information is somewhat filtered, so he does not get all the information. So we configured not only the applications and the events, but also the schemas. I just want to have a bit deeper look in what our schemas and what our topic structure might look like. In here we see that we have, let's just get on the event, and we see that we have a topic where we have a country, we have a market, we have the information that we bought an article, and that we want to register this information in our systems with a specific article ID. Additionally, we have our schema. We just want to expand the schema with small properties. So we have the market ID, the article key, the article ID, and some details. So the article key is actually a group of articles, so that we have a specific article. Let's call it, for instance, cornflakes. So we have the cornflakes, and then we have the specific article. So we might have a million of cornflakes of one cornflakes type in the end. And this information is being filtered to only let through, and let's have a look at the JSON schema for the filtered version, the market ID, the article key, and the article ID. So the difference between those is actually that all the detailed information we had in the string is not being transmitted to our supplier, but only the information which article ID was actually consumed or bought. So from here on, we want to build a small microservice that is able to receive or get the article bought event, transform some data, so actually filter some data out of this message and push it back to the system as a new event. And for that, we want to utilize one of Solace pretty cool features, and it's called async API generation. So Solace cooperates actually with the async API initiative. So the async API initiative defines an industry standard how applications inside an asynchronous world are communicating with each other. So Solace not only provides you an interface with that or generation tool, but also is one of the sponsors or main sponsors for this async API initiative. And accordingly, or maybe because of that, they also have a cool feature implemented in the designer. So this is why we're actually using the designer. So we're able to click on one of the applications, click on the three dots over here, and click on async API. So an async API is a generator or might use a generator tool. So what we want to download here is an instruction for a generator tool to create or boilerplate a small Java microservice for us, which just utilizes the Spring Cloud Stream framework. So we want to download it and have a look into. So this is the YAML we end up with. The YAML itself contains an information for a generator tool to tell the generator tool what it should generate in the end. So what we want to receive is a Java boilerplate that is just waiting for us to implement some business logic, but in the end everything is being taken over by this tool. For the tool to work, we have to handle some parameters, and that is being done by the designer, as you've seen. So this file received by the designer just needs some configuration, and then we can just put it into the generator tool. On the one hand, we have the schemas, which just match the designer or the design decision we've taken on this small use case. So we have the article bought event within schema and the article bought filtered schema. So they here you can see that in the filtered version, for instance, we do not, or in the article itself, we have the specific details field which we don't have in the filtered version. So what happens with those is they are going to end up as classes that we can just fill up as we want to and use them in our program and code later on. On the other hand, we tell the generator that those two are actually the messages we're talking about. On the other hand, we have the channels. So the channels implement the publish and subscribe part we just defined in our designer. So on the one hand, we subscribe on the information that an article was bought. On the other hand, we publish the information with the filter tag. So we've published a filtered information. For the generator tool to work, we actually have to change the static or the flexible fields to static to a static topic. This is just for now for the generator tool to work. We might change the spec later on, so that you can go to the mightiness of Solace to use the star and greater than subscription. And that is no problem at all then. Additionally, Solace provides some information on their own how to use the async API. They also provide some information about the functions and the channels and how to combine them. So there are some custom parameters we want to have a look, or actually one custom parameter, which is the XCSC function name, that is helping you with our use case, because what we want to have is we want to have a single function that receives the message, transforms a bit, so this is our business logic in the end, and then pushes it back to the system. So we don't want to have a big logic tree inside our application. We just want to have a simple pub/sub model. So for this to work, we are handing over this small parameter with a saying function name. So this is actually going to end up as a Java function. So we call it filter article. And this is the same we want to do for the subscribers. So they end up actually in the same function. Okay, from here on, I will show you in a second how this generation itself works. the generator tool itself is an open source project by the Async API initiative. And the Async API initiative tells you what parameters to configure to receive the wanted result. The tools, or actually the parameters we used, I'll just go explain them in a bit. So we want to define an output folder where we want to put all our generated code into. We have on the one hand defined that we using the Solace binder, so that the structure that is being returned by the designer is understood by a generator as a Solace binding. And we want to define the application name, and the Java package everything is being put into. Also, we have our standard Solace connection information to connect the application in the end to our broker. So we have the host, the username, password, and of course the message VPN, which is currently for us the default. Additionally, the file, of course, is an input, and then the template. So the file generates, or the generator generates, or boilerplates as some Java code, and we're going to have a look into it with you together. So I already run the generator and imported the project. First of all, it returns a Maven project, which mainly implements the Spring Cloud framework. The Spring Cloud framework actually Solace goes pretty well with the Solace Spring Cloud framework, so I have the integration for that. And mainly the application, what the application does, it receives an article, does some business logic, and returns the filtered article for the supplier. So this is what we actually wanted to do in our architecture. Additionally, as I told you, we have the schemas being turned into article and article filtered for supplier classes. We have all the getters and setters for those attributes, and so we can use them as simple objects. So basically what you want to write in here is some Spring magic. So we receive an article and we want to do something with it. In the end, we just want to return actually a new, but we want to return this one, and we want to return a new article filtered for a supplier, where we are going to fill in into the constructor all the information needed. So we have, let's have a look in the order. So we have the article ID, we have the article key ID, and the market ID. So we extract this information from the article. We extract the market ID information from the article, and we extract the article key from our application. Let's just have a check whether we got it right. Article key market, article key and market, and with this information we return the build article filter for supplier. So this is actually everything we need to do, but first what we want to have a look into is whether system out print line, whether we receive actually any message. So message received, so that we have an information not only in logs but also for us to see whether this worked out. Okay, so let's just fire up the application and see whether it connects to our broker. So now it says connecting to host, and this should just take a second. And then we see this again when the connection is stable, and we can test it against our application. Okay, so the application started and connected to our broker. Actually, I had to adapt in the application YAML configuration file our host with a port. So had to do this, and then we were able to connect. What we are going to do next is we are going to have a look whether our application works as intended. So first of all, we are we're heading to the Try Me tab of our Solace PubSub plus broker instance, and connect with the credentials we can steal from here actually. So we can go with the admin, password just for test purpose, connect a publisher, and we also connect a subscriber, and then we steal the destination and the for the destination for the subscription, this destination for the publishing. So on the one hand we have the event itself, so we're going to publish to this topic, and on the other hand we are going to subscribe to the filtered article. So there it is, and the direct mode is okay. The message itself, we head over to our designer. We go into the article board event. Let's just open it, and let's click some view details on the schema itself. And with the schema, we should on the edit tab actually be able to receive some example data, right? So here we have our schema, and then we have example data created for us. So we can insert this one in our Try Me. So let's put it in here and let's publish it. So he received an article, and I'm just wondering whether why this is not okay, I forgot to subscribe. Maybe that's it. Okay, so I got the message, so I sent the message to the microservice. The microservice processed now 2 messages and returns the output as required. So in here we see we have the article key, we have the article ID, and we have the market ID, and we don't have the details. So this Nastred alec is actually missing, and this is exactly what we wanted to see. So basically this is how you easily utilize the async API generation tool for boilerplating your Java microservices, and from here on it's only a few steps to pack everything up into a Docker image and push it to Kubernetes, so that you have your microservice running in your Kubernetes as well as your broker. So you have one system set up. So that's it for this topic. In the next section I want to see the whole system working. So I want to add the RDP point, and then if this works, we received our goal, and but see we're at the RDP configuration. Okay, so the final step is going to be to create a connector, an RDP connector to the Azure function, and therefore we are going to utilize a fairly new feature of Solace, which comes within the UI. So we have going to click on our connectors tab in our PubSub plus broker instance we just created. Click on create a new connector, and so that we use the Microsoft Azure functions. We're going for the Microsoft Azure and functions configuration, and click on the authenticate tab. So in here we first want to use a saying name. So this is the headset article bot persistor so that we want to that we know, okay, this is the instance that writes the information to the database, to our Cosmos database. Additionally, we want to provide the Azure function URL. We get this URL in our service as such. So here we have the service Dominik just wrote, and here we have the get function URL tab, and here we want to go for the master and copy this one and enter it in our connectors tab. So there we go. And then click on connector setup. And right, from here on, everything should be autopiloted, right? So we have our default client profile selected for now, and an access key, as well as the Azure function setup. So continuing with this setup for the subscriptions, we are going to go for the ones we defined in our example. We are actually using the bases we defined in our designer, and we're going to generalize them on in a Solace typo. And the register, we bought an article and we want to register the article ID. So from here, I just want to do, let's do a star subscription actually. So, and then we, or yeah, just a quick surround. So why I want to select a star in the end is because I don't want to go any deeper. So if anything comes like this, I want to ignore it, because for now we defined our designer that we want to go in this depth with our subscription topics. So I'm not going for this greater than sign. So we are ignoring all the topics that come after that. But basically first I just want to go for this depth. So from here on, we just click on create and enable control, and we see the operation status instantly up. That is amazing. So from here on, we click exit, and we see that we have one connector defined, an Azure function. Okay, so we want to check in the try me tab if we actually get something through. So since we defined our test or generalized our test topic, we will actually receive this one in here. And therefore I just click on publish. And now we check in our Cosmos tab from before whether we received anything new. And actually you can see that we received entries. So now we fully defined our whole design process. So let's go back to designer once again and have a look whether we received or actually got what we wanted to have. And we have the checkout system, which says, okay, article bought. So this is what we simulated with the try me. So this is actually an article that is being bought. So here we could say this is the market ID in Frankfurt, for instance, or make in Frankfurt. We have article key is cereals. We have the article ID 42. And the article details is this is secret for the suppliers. So we publish it. We see that on the other hand we have the subscriber which deals as a supplier at this point of time. So if you have a look back and through this, we're currently having the try me at this end, and we are receiving the information without the secret information. So our microservice we just wrote, and it just received the article as well. So you see, okay, this secret is for suppliers. It received this information and filtered it out. And on the other hand, we received it in the Cosmos DB, so that we now persist this information in our systems.
Yeah, finally we calmed the storm. As you can see, we were able to build an end-to-end pipeline in just 60 minutes about. And hopefully you can try it out as well. And if you need some help, just get in touch with us, write an email, or give us a visit on the LinkedIn page. And yeah, thank you very much for visiting us.
Yeah, thank you very much and have a great time.